The broadcast is now starting. All attendees are in listen-only mode.
Hello.
John.
Hi, John.
John, can you hear?
Hello.
Hi,
Is
John.
that
Can you hear us?
yes? Very well. Is that Irfan?
Irfan and
Yes. Can
Rakesh.
you hear me? Okay.
Yeah. Did he send you the
Yeah.
presentation?
Very nice to meet you. I appreciate all your help with this.
Um, okay, John, would you be running your own presentation or do you want to send it to us?
I think I'd rather run it if that's all right.
Okay, that's fine. Abhi? Okay, but can you also share it with me or through email?
Yeah, absolutely.
Yeah.
I'll send you a copy.
Yes, and you can run it yourself. Irfan, what else?
Yes.
इरफान और क्या चेक करना है आपको? John, can you hear me?
Yes, very well.
So, Martin is going to be with you, right?
He's in London, so and I'm in Oregon on the west coast of the U.S.
Okay, so we have to connect to Martin as well. So, okay, give us a few minutes. We'll connect with Martin as well.
okay, thank you.
Yeah. Hi, John.
Yes,
Would you be presenting first, or would it be Martin?
I'll be presenting first.
Okay. अब Martin को कैसे- some more of our guests to arrive, so like another 2 or 3 minutes.
No worries. I trust your judgment.
Okay, thanks.
You're connected, so you need to transfer that 57223. So you're talking.
Thank you for holding. We are sorry to keep you waiting.
Well, if you're still connected to that number, we should be in it.
I just pressed the transfer again.
But was you still connected to that call?
Yeah.
Go on.
Do it again?
No, because we should be in the call. If that's what the decision. You meant to pin all that, didn't you? You didn't hang out any of that up, did you?
Hello?
Someone. Hello?
ये कर लो बेटे फिर मैं शुरू करूँगा.
Hello?
Yes, John, can you hear me?
Hi, Martin.
This is Martin Schuler from London.
Yes, Martin, can you hear me?
I can hear you perfectly well.
Excellent. Welcome. And I think your line is not very crisp. You want us to dial you again, or you want to try again?
We're just proving communications at the moment, so give us a minute or so.
It's much better now. I think
is John on the line?
Yes.
Yes, I am.
If you're closer to the mic.
Hi there, John.
Excellent.
So.
Okay, and John, you're there?
Yes, I can hear you both very well.
Welcome. Very happy to connect with you.
Yeah, I feel the same way. I'm grateful for this. Thank you.
And thank you for agreeing, and thank you also very much for reaching out to Martin's shoulder. This is remarkable.
It's a pleasure here. Good morning from London.
Good morning to everyone.
Good evening.
Okay, how do we get that on the
Let me first of all welcome you all here. Before I introduce you today's very distinguished speakers, let me introduce you to the series. What is this series about? And some of you already know about this series, so please allow me to repeat myself a little bit. And then even before starting with my today's speakers, I would like to introduce you to my next speaker in this series on July 11th, so that you are informed of what is coming next. So I hope, John and Martin, you can bear with me. Pakistan has many water challenges. And one of the challenges that I think we need to think more deeply about is that Pakistan gets more than 80% of its water from its neighbors. How best we use it will depend on our management systems. How much we get it and when we get it will depend a little bit on our scientific understanding about river flows, and a little bit about the political relations, and a little bit about the collaborative understanding or agreements or instruments of cooperation or collaboration that we can have. From Kabul River Basin, we get almost 20% of our water. And that's water that is early riser. It comes when this country needs water desperately. And when Pakistan needs water desperately, lower riparian Sindh says that Punjab doesn't give us water. That is the time when the Kabul River water becomes more important for us than water itself, because it has political implications as well. It has implications for the political system and structure. 4 districts that border Punjab use water-intensive rice, and they demand water, and they're politically very strong person. The remaining water we get in this water, remaining water in this we get from India, and then upper Indus countries such as China are becoming also important, because water melting and snow melting there is happening with increased pace because of climatic changes. So Pakistan has 3 significant water neighbors in the Indus Water Treaty, in the Indus water system. Realizing this thing, Pakistan last year initiated a series on managing shared waters. In that, we are trying to see what are different aspects or dimensions of managing water that you get from it. It is within their power, rightly or wrongly, to construct reservoirs and give you less. It is within climate change science that the quantities may be diminishing in coming decades. It is within the realm of possibilities, scientific possibilities, that the glaciers recede and they result in permanent reductions. So the challenges are manifold. And we talk about transboundary, so the boundaries are between sectors as well as between countries. These are between provinces, and these are between neighbors, such as sectors in Islamabad, as we use this word. Just to give you one example, the water scarcity in cities like Karachi is in competition with use and sometimes less careful use in the agriculture sector. The cities will get less if they also need. So the competition of water is huge and will increase. Based on this kind of understanding, and I don't want to take more time, we have this series that every other week we try to bring a speaker in the country or from outside who, based on their expertise and understanding, share some knowledge with us. It is also live streamed as a webinar, so some people join us, and we don't know who they are very often. They may not know Urdu language, so we end up speaking English most of the time. They may be in Malawi or Peru, we wouldn't know. So sometimes you get excellent feedback from people who come from the other regions. For example, one of our speakers and John, you'll find it very interesting. On 25th of July, we'll be talking about water basin management agreement between Armenia and Turkey. And they came to us only through webinar. We didn't know that they were managed. So it's a learning forum for us. In this series, we have covered all kinds of water-related issues dealing with water management and water basin. Most importantly, 18 speakers have cycled through. And I have calendar in front of me for 36 speakers. So after December, we'll continue. If you continue, we'll have the series coming. Now, I hope John and Martin, it was useful background information for you. I want to just spend 1 or 2 minutes on our speaker next week. Next speaker on 11th of July. She is Dr. Afreen Siddiqui. And the first pleasing thing for me personally is that very few female water specialists are in this country, and mostly male driven. Even though all of us recognize that water is essentially a female issue as well. And she's a very distinguished scientist at MIT. She's the research scientist at MIT and an associate director of the MIT Strategic Engineering Research Group. She's also a visiting scholar with Science, Technology, and Public Policy program of the Kennedy School. She has a PhD in aerospace systems from MIT. Her expertise in quantitative modeling and systems analysis, and therefore everybody from PMD should be here next time from GCI. Very happy to welcome you, but we want to see your colleagues who are better informed about modeling and systems analysis. Her current work is on investigating emerging critical linkages between water, energy, and food, which is looking at nexus issues. And many people who come from non-profit sectors such as you, it should be interesting for them as well. And infrastructure investments, and this is a very important area of work that's emerging, that our infrastructure, because of climate change and increasing disasters, is under threat. And I can go on and on. So I want to request you before coming to today's topic, that 11th of July, Wednesday, please mark on your calendar, and I will see many of you, and those of you who are on the webinar, to you as well. With this background, please allow me to introduce you to today's 2 speakers. In the flyer, you have John Matthew listed only, but I'm very happy that he reached out to another very distinguished practitioner and scholar on water issues, Martin Shoulder. He's also joining us. They're joining us from 2 different countries. John, where are you today? John,
I'm in the U.S. I'm at home.
Okay. He's in Colorado at home. And
yes.
Sorry, say it again.
Yes, I'm at home.
And Martin is in London. So we are very fortunate that we are able to connect to them because of technology. Just a quick introduction of John before I give mic to him. John is a very versatile and a very polished and refined activist also. From my personal observation and work with him and friendship with him for the last several years, I can share only one thing with you before I read this. And John, please don't embarrass me by correcting me. In the climate change negotiations, he was leading a process to help mainstream water issues into climate change discussions. And that was quite successful by the time we signed Paris Agreement. Every issue requires a champion and advocacy group, and it requires a lot of systematic engagement. And it requires very strong organizations supporting you. And John was fortunate to do that. He had personal energy. to commit that, and he had support from many, many people working on this. And today's climate change negotiations globally and climate action is incomplete without thinking about water. So John spearheaded that advocacy in the climate negotiations, climate discussions globally. He's a co-founder of the Alliance for Global Water and Adaptation, short named Agua, which in Spanish means water, like in English, Agua. And that group is chaired jointly by World Bank and CV, Stockholm Institute of Stockholm International Water Institute. And that's a premier research institute based in Stockholm that for the last 25 years, or 26 years by now, has attracted who's who on water issues globally once every year. And they have helped shape the global climate change discourse, including shaping up the work and the direction of GWP, Global Water Partnership. John has worked in more than 20 countries, including Pakistan. He's extremely engaged on climate finance issues for water. He's extremely engaged on a range of other issues that means climate resilient development, including infrastructure. John, welcome, and we are very fortunate to have you this afternoon. Can you hear us?
Thank you so much, Ali. Yes, can you hear me all right?
Yes, I can hear you, and I want 1 more minute to introduce Martin, and only one. Okay, we'll do that later. John, on to you, please.
All right. Thank you very much, Ali. I'm very honored to be invited to speak on behalf of Lead Pakistan, and I'd like to say, as an individual, I am a real friend of Pakistan, and that I tend to disagree with my current government, and I've been to Pakistan several times, especially in Punjab, and working with the provincial government there. Today, I'd really like to encourage a dialogue with Martin, an interactive dialogue between the people in this session, and perhaps those who are hearing it afterwards in a recording, to talk about what urban resilience might look like globally and in Pakistan in particular. I'm going to be using global examples from cities and cases around the world. And I'm going to be talking about what resilience means and how different definitions, different perspectives on resilience can lead us to thinking about different types of actions and different types of active actions and how we respond to climate impacts that we are experiencing now and in the future. I'd ask the organizers to let me know if you can't hear me very well, or if the sound quality is not good. Otherwise, I'll just continue on. In overview, I'll be providing some context about a kind of landscape of emerging issues and approaches, and then I'm going to hand it over to Schuler, who's a colleague with a global engineering and design firm that's based in London called Arup, and he works at a very high level on their water team, and very much on a specific program that focuses in urban resilience. So he'll be going into more detail about some applications of some of the concepts that I'll be talking about. And I'd like to first start off by saying that if we think about the landscape of issues, especially around water management issues, that we're in a time of real transition. just about a year ago, I was in a small private World Bank meeting. I heard a very senior manager. This is a man who literally controls and influences tens of billions of dollars US each year on water management issues. Say, we build things that last 300 years. Why don't we think about sustainability for that long? And in the context of cities, it's actually an even more extreme statement. Cities like Lahore were visited by Alexander the Great more than 2,000 years ago, and it was a vibrant and well-developed and living city then. Cities last a very long time on the landscape, and often, in contrast, we have a very short term view on what sustainability might look like, and that has a really big impact on our thinking, on our actions in a time of rapid climate change like we are in right now. From an international aid agency, just this year, I heard again in a very small meeting, a senior manager say climate change is now happening too fast, and we're not adjusting to those impacts, to the scope of changes, to the scope of actions that we need to be able to make in response to climate change quickly enough. And that is absolutely in the case of urban issues. In Pakistan alone, right now, Karachi is having, again, a very serious year of extreme heat leading to death. In my work in Lahore, I met very many leaders and representatives of civil society who are working both at a level and at a city level, who are very concerned about the pace of change, how cities were interacting in new ways, not always positive ways, with other types of forces and decision-making processes in Punjab. In my experience, actually three different visions, three quite different definitions of what resilience looks like in the community or management decision-making processes. Perhaps the most common definition of resilience that I see is among people who work much on a disaster-based response system. So these are people that might have to deal with floods and droughts, as Pakistan has certainly deep experience with other types of extreme weather events, such as the extreme heat in Karachi, perhaps with typhoons, maybe even earthquakes. It's not necessarily a climate vision of resilience. And there's a strong sense of how quickly do we get back to normal. I think of this as rubber band resilience. You stretch it, and then it comes back to a resting state. So recovery is really the most important word in this type of resilience. In the climate change community, you often see a very different definition of resilience, that there's a recognition that there may be more than one type of stable state that a system can exist in. So, I'll provide an example of that later, but over the longer history of Pakistan, especially in areas where the great rivers, such as the Indus, flow from the Himalayas, those rivers have changed quite a bit in their flow regime and the precipitation regime that drives them over a scale of centuries. And often we have very little influence, really no influence at all over what that particular stable state is. So there may be a drier set of conditions, a wetter set of conditions, for instance. And which of those is normal? They're both normal at their own time, but when you're in a time of transition, as we are in now, what are the issues that we face for those transitional processes? What do we aim for? What do we think of as our targets? In the water community, I think actually it sounds like one of your upcoming speakers is an excellent example of this that Ollie had just introduced. And across the broader water community, a very deep sense that's not incompatible with these other two definitions, that water really needs to be a kind of resilience connector, that we need to think about many types of sectors such as energy, agriculture, different institutions that influence water management decisions, the environment, and thinking about upstream, downstream, and transboundary relationships. So nexus thinking, transboundary thinking, a multi-institution thinking for resilience. And certainly in an urban setting, this perspective is absolutely critical. But the other two definitions will influence our sets of actions. Essentially, water is, from a scientific perspective, I'm an ecologist by training, a water scientist. We talk in science about water being a non-stationary resource. That is, that the past does not always become an effective predictor of the future. These are photographs from the Gambia River in northern India, where I used to do a good bit of work in the extended Ganga-Brahmaputra basin. At the time, I think this is around 2007, the Gambia River had been dry for about 5 years. It has, to the best of my knowledge, remained dry since then. This bridge in the background is over a Kalong, and there are large trees that are growing in the basin of the river at this point.
Sorry, John, can I interrupt you for a minute? Are you running your slides?
Yes, please, Ali.
Are you running your slides that we are not able to see, or you're not running your slides as yet?
Oh no, I am. You can't see my slides?
No, we are not able to. Actually, we are waiting very patiently, thinking that after the introduction, you'll begin with the slides and stuff.
It shows that I'm sharing.
No, not yet. Do we have a copy here?
We can run it.
We can run it from here on and share slide, and you'll be able to see also. You can ask us to move.
We can run it for you. You can let us know when you want to go to the next slide.
But right now we are able to see only the front slide only.
We're on the first slide right now.
The title slide.
Okay. Yeah. You've made me presenter.
Yes. Yes, we did, John. Presenter.
Oh, there. Can you see it now?
Not yet.
How about we run it for you? What slide do you want us to run right now? And then you can keep saying next.
Now it's moving. Now it's moving? Yes. You want to run it? Go to slide number 1 on the title page.
Okay. Can you see a photograph now?
Yeah.
Yes, we can.
Okay. All right. Thank you for intervening. I really appreciate it.
We are on how do we value non-stationary resources? Yeah.
All right.
Gambia River, India.
Okay.
And we have not seen any
All
of
right.
the previous ones. We want to quickly give a summary.
I'll just move along. All right. How do we value non-stationary resources?
Okay.
As I was saying, that our idea is from a perspective that the past is, in a time of rapid climate change that we're in right now, not necessarily a good predictor of what kinds of conditions that we'll be facing in the future. And I'd like to just suggest that often we have when we're thinking about many resilience decisions.
John, I'm sorry about this. It's gone again. We are again static on the same slide.
We have. Yeah, I mean, I've suggested that twice.
Now we can see it. We can see it, but we can't run it.
Okay. All right. Oh, let me know if it stops again.
Okay.
And one of my as Ali was saying, I've worked in many countries on many different kinds of projects. One of the areas that I've been very much struck by is that we often don't have a good sense of the value of water, that we don't capture its full meaning. And I think climate change really brings out that emphasis very strongly. As I was alluding to earlier, this is the Gambhir River in northern India, one of the major tributaries for the Ganga in India. And for instance, when we use strictly an economic frame of reference, there are many people who live in this particular basin that the sense of it, the river's view, very much lost. Many of the practitioners of Hinduism, for instance, as you can see in the upper photo here, they've brought their relatives for cremation. But the river at this point is mentioned for 5 years, and it's been dry for another 10 since then. The value of water is often expressed as stress through many different levels that an economic lens is often not capturing a very full vision. Here's how the World Bank sees climate change and the value of water as a non-stationary resource. This is an economic analysis program, and each one of these lines represents a different management scheme and for the World Bank. You can see across the top of each vertical line a different variable, literally going through hundreds of variables to try to understand the full spectrum of types of solutions that are available. And the final measurement is really in the far right column, which is expected net present value in US dollars, measured in millions, and as you can infer, in billions for one particular investment in this case. So I just wanted to show these as a contrast that non-stationary resources are really that they're making profound shifts in how we think about the value of water, how about thinking about our options and the direct economic impact in the case of a group like the World Bank, but also really stressing social, cultural, and even religious and gender systems for the rest of us. This is a woman, she stepped down, she's retired in the past 5 or 6 years, but she's arguably in the last century the most famous and most powerful single water manager in all of North America. Her name is Patricia Mulroy. She managed a water basin authority, particularly for the city of Las Vegas in the US on the Colorado River. And she is famous for coining a phrase that climate is the invisible utility. It actually is we think of it as something that delivers water sources in a reliable and consistent manner. But it's also a utility that is itself evolving and stressed right now. To use a scientific term, it's non-stationary. And that leads us to directly in her area, the example of Hoover Dam, which is one of the great pieces of modern engineering in US history that we built over the past 100 years. It's coming up on about 90 years old now, started in the 1920s and 30s. And the Hoover Dam is really the kind of three gorgeous dam in US history with a face that's several hundred meters high, generating a lot of hydropower, storing water for agriculture, and also providing flood protection. And if you see the white line behind the face of the dam, that's about 40 meters high in the photograph. It's actually much higher. I flew over it at about 10,000 meters last week, and that's called the bathtub ring, and it really measures the gap between the climate that this dam was designed for in the 1930s and the climate in which it exists now. That's a huge gap. The dam is actually in severe threat of being able to lose even its ability to generate electricity, and that electricity is needed to be able to pump water to cities as far away as Los Angeles, hundreds of kilometers away, and to the most productive agricultural lands in the U.S. At this dam, it's not too extreme to say, this dam took the southwestern region of the U.S. from about 200,000 people in the 1920s to over 20 million people today. It was that critical, that important. And this potential mismatch between our systems, especially our infrastructure-based systems, and the climate in which they live now and in which they will live over their long lifetimes is extremely important. It's all very, we don't really have, in most cases, good ways to be able to think about how those systems will change over time. That's where our definition of sustainability, our definition of resilience is actually really critical. We typically use very poor indicators for sustainability. When will we be paid back for building something? When is our next election, and what will that decision maker or policy maker do? Or in the case of a company, when do shareholders expect dividends? Here's a very different kind of example. This is from Sichuan province in central China. This is the Duzhongyang irrigation facility. This is also a piece of infrastructure that serves roughly 20 million people for irrigation purposes. It's over 2,000 years old. It was designed by a single engineer. It even has an integrated fish ladder that was developed at the time that it was constructed. It's a very impressive piece of durable and sustainable planning and design. And in this case, what I would infer is that the institutions and the engineer who originally put this together, that they maintained a perspective of how long can this last? How long can we make sure that it stays working? And also maybe what comes after it, and what are the complex systems approaches that we need in order to maintain it and to keep it fit into a complex environment. Really, I think it's an example of humble approaches to water management. This is one of my favorite quotes. This is on Halagat. He's probably the most famous, potentially the most important climate change economist. He's based at the World Bank. And in an essay with a number of other writers, he wrote, many decisions have long-term consequences. Infrastructure in particular can shape development for decades or centuries.
John, can you hear me? I'm so sorry, we are still stuck.
Yes, very well.
Slides. We are still stuck on your previous slides. We have not moved since Patricia Mulroy's quotation. Now we can.
You can only you can't see any other material that's come up.
Now we see your quote on many investment decisions have long-term consequences. Just appeared.
Yes. Okay. That's good. Yeah, that's it. All right. It sounds like it's just going through your system a little slowly then.
Okay.
Infrastructure, in particular, can shape development for decades or centuries, a duration that often extends beyond infrastructure's lifetime, because the economic system reorganizes itself around those systems. And I would argue that ecosystems and even social systems do very much the same thing. The groundwater crisis in southern Pakistan is an excellent example of this type of reorganization. So are the massive irrigation systems that we see in Punjab and southern Pakistan and eastern Pakistan that date back not just to the British era, but even to the ancient Harappan civilization. These are profound shifts that are often lost in discussions about climate impacts and climate adaptation. This is another example from South Asia. This is a small hydropower dam. At the time that I saw it, about 2010, I believe, I was in the Koshi Basin in eastern Nepal. This is a run-of-the-river hydropower dam. There should be water that's flowing over this dam. And what we see, unfortunately, is a completely dry dam. It's an underperforming dam. It's only producing about 80% of the hydropower that it needed to. And there were about 4 kilometers of dead river below this dam. And the problem here is actually the same problem with the Hoover Dam. That it's, even though it's small, it's only about 6 meters high. It was designed using the same assumption that the past is a predictor of the future. And because of the rate of change that we see now in the Hindu Kush, in the Himalayas, across South Asia, we have investments now. We have systems that are being developed now that at the time that they begin functioning, they do not match the climate in which they live, because we're not thinking forward very effectively. So Nepal took a loan out to build this dam. They're not getting the electricity that they need, and they've killed a river. So they've lost many of the livelihoods for that system. This should be very concerning to all of us who work on the concept of sustainable development and think about the future. A brand new underperforming dam. I could stand at the base of it and look right up into the white mountains of the Himalayas and see the snowpack there. That is representative of the pace of change that we are encountering today. I would even go farther. I would say that our approach for think about the future in light of climate change over the past 20 years is deeply flawed. These are again some slides that I borrowed from Stefan Halligat. And to maybe make a more extreme point than even he was making, I think we're almost like junkies with how we use climate model information. So if we look at, this happens to be a French model, a French global climate model, looking at a projection from West Africa. If you follow that point, the green areas are getting wetter, the brown areas are getting drier. But here's another model. This is an Australian model, and it shows really very different kinds of impacts that are happening in the same region. If you're an engineer, you're a water planner, you are the mayor of a city, you're trying to do long-term planning processes, you're trying to build a piece of infrastructure that will last 300 years. Which one of those do you pick? Unfortunately, there are a lot of models. The major models recognized by the IPCC are roughly 24, and there are others beyond that, including many regional climate models. And each one of those models then goes through multiple scenarios. So in effect, if we were to use all 24 models, all the scenarios, we might have close to 1,000 different predictions of the future that we need to sort through. And especially for the water cycle, our ability to choose to select which one of those is correct is pretty limited. And there's a massive amount of variation and uncertainty between those models. So not only do we know that the past doesn't predict the future that well, but we also, for the past 20 years, have had a very weak approach for how we think about the future. So this is exactly the space where my organization works. We're called Agua, the Alliance for Global Water Adaptation. We're actually almost 8 years old now. We'll turn 8 in August, and we're a little over 1,200 global water and climate professionals. As Ali mentioned, we're co-chaired by the World Bank, the Global Water Practice, and by CIWI in Sweden. A very strong sense that we emphasize best practices. We also do strong global policy work. But ultimately, what we really want to be able to do is capture the new sense of best practices for technical water professionals, water decision makers, even if they don't necessarily think of themselves as water decision makers, as you often find at the urban level. People making water decisions who don't necessarily think of themselves as water people. So I'd say I've framed this slide as a problem, but I'd also maybe flip it around and say that there's an opportunity here too. Water resources management is strongly quantitative in framing, implementation, and decision making. Engineers need to have a pretty good idea about what the future might look like. Planners do too, that they can give credible options to decision makers, to civil society. But they need numbers to be able to do that. They need numbers that they can believe in. And climate change increases the uncertainties around providing those numbers, reducing our confidence in estimates of those emerging patterns. Well, water here is, water may be the primary stressor with the full range of types of impacts that I've been discussing, but it's also an opportunity. It's an opportunity to provide a linkage across sectors, across institutions. And in most cases, if we think about ecosystems, I would say social systems here too, and infrastructure, we really have a very low tolerance for failure. The great floods and droughts that have occurred just in the past decade in Pakistan are excellent example of the deep implications, such as the Great Indus flood of 2010, just a catastrophic event. So how do we usually make these kinds of long-term decisions? The kind of global standard really has been what is now called a top-down approach. We start with a decision maker. That decision maker defines a problem or a need. A technical analyst, probably an engineer, but it could be a hydrologist, an economist, a finance person, develops a single solution. They may include some information about climate change, and then the single solution is just presented to the users, civil society, and stakeholders as the option that we will go with. It's a very inflexible approach. Users and stakeholders are often not involved at all, and from my perspective too, climate is one driver, but it's not the only driver that is occurring. Ali also alluded to the negotiations between India and Pakistan on the Indus right now. I was in a meeting just last week with the World Bank where this came up. The World Bank is one of the hosts for these negotiations. There are many aspects of technology, of society, that are also changing at the same time as our climate. That complexity is really challenging right now. And I I like to think that that we are transitioning into a new state. I think of it as a post-optimization era. That is, that we're not just focusing on one single solution, and we're also trying to alter the groups that are involved in the decision making and when they're involved in the decision making process. Really taking that technical analyst, working very closely with users and stakeholders to have them define a sense of what a problem or need is, and then developing multiple solutions, not just one, making sure that climate risk is integrated very deeply into that process. And then the decision maker probably won't just pick one solution anymore, probably will think about several that then need to be staged over time so that they come in as an evolving process. This is much more of a systems type of approach. And this contrast between top down up goes back to what I was referring to earlier in terms of our definition of resilience. Top-down assessment really looks at trying to estimate what the potential impacts are at the beginning of the process, and really just inform stakeholders or decision makers what those predictions are, and then you cross your fingers and you really hope that that information is correct. But these bottom approaches, they're quite different. They're really beginning the people who have the most at stake, who live in the basin, who really understand the complexity, the types of systems that are there, and understand the limits of those systems. You can use climate data from GCMs or from other sources, but you don't let them define your problem for you. And then the definition of resilience here is critical. In Agua, we've come to understand that resilience has two primary components, that you need to be robust and you need to be flexible. Robust refers to being comprehensive for what we think about the range of possible issues, opportunities, and challenges that we may be facing in the future. And flexible means that we need to make sure that we don't rule out potential options if we're faced with a lot of uncertainty. This is very different from how we have been making water management decisions, urban decisions over the past century and a half. These methodologies, these bottom-up approaches, are starting to become much more systematized and rolled out for individual decision makers and decision-making institutions. On the left is an excellent World Bank guidance called the Decision Framework. The World Bank is an important player in water. It actually plays quite an important role in Pakistan's water management decisions, especially with some of the big influences. The World Bank does as well. They play an absolutely critical role, and they're also a close partner inside of Agua. The World Bank alone globally is spending around $22.5 billion US on water investments, and all of that money needs to go through this methodology on the left, the decision tree framework. So this is that book only came out around 2015, and already we a real reorientation that's been a powerful signal to many other types of decision makers. I'm going to talk about the item in the middle, CRIDA, Collaborative Risk-Informed Decision Analysis. In just a few weeks, I saw galley proofs yesterday. It's being published by UNESCO and their International Hydrological Program in Paris. And this is really aimed at individual water managers and technical decision makers. Many of the examples are urban examples, and was put together by an impressive set of water institutions. In the US, the Army Corps of Engineers, one of the main technical water management institutions in the US. In the Netherlands, the Infrastructure and Environment Ministry, Deltatus, also a very good friend to Pakistan, a water think tank and research and action institution based in the Netherlands but working globally, and the University of Massachusetts at Amherst. I'm not going to talk so much about the product on the right, unless maybe there's some questions later about how we blend ecosystems into this approach as well. But this is also a well-developed methodology that's been published too, called EADS, Eco-Engineering Decision Scaling. So CRIDA is a methodology that, as I had alluded earlier, begins with a shared vision. The technical analyst working with the stakeholder, the decision maker, to really try to articulate, to translate their needs into a particular quantitative framework that is described by a set of performance indicators. They could be purely economic, but they might be looking at other types of variables too. In the case of Karachi, it might be based on heat stress. It might be based on groundwater supply, maybe agricultural productivity, stormwater conditions, and so on. These are then placed into a stress test, and then we try to develop first a robust solution. That's through a methodology called decision scaling. To develop a flexible solution through a methodology called adaptation pathways. And this is a very different kind of approach for how we think about climate impacts than the top methodologies, because it starts with what we know about the system, we know about those stakeholders, and it gradually moves into thinking more systematically about the limits of our knowledge and where we might need to make a different kind of decision, a more humble decision for the future. This concept of a performance indicator is actually quite critical, and we look at these issues. If we think about measure performance, let's say that it's relating to floods. If we think in terms of getting real water stores in a city, for instance, system structure, the severity of a particular flood, there is some breaking point at which a small problem becomes a very serious problem. That's in the language of CRIDA, that's called a breaking point, or an adaptation tipping point, when we know that we need to make a different kind of decision. And we can define that as a critical threshold. We can define that in most cases with stakeholders in a quantitative way. That leads us to also to think about what's the plausibility, what's the reality of reaching that point. This is an example that was developed by Deltatus and a university in the Netherlands, Wageningen University, and as an example from South America. This is a city in Ecuador that they identified more than one level of performance indicator, one level of a breaking point that they needed to manage for, and it's really based on the intensity of precipitation that occurs and what they can live with. So the first, this is a high rainfall area. They can live with very reduced impacts on really quite minimal impacts on economic activity, with relatively frequent small floods. So 20 centimeters of flooding in the streets, which seems like a lot to me where I live, but the systems people have there, they're flexible, and they can adjust. That is normal, in fact, to them. In fact, during the rainy season happens 3 times a week. The second level are flood events that are more than twice that. Currently, these occur about once a month, and this actually causes an economic impact that lasts up to a week. So it's an important disruption. And want to minimize that. They think that maybe once a month it would be the most that they could tolerate. And the third level are when there's 60 centimeters or more of flooding, and that's when there's really catastrophe in terms of economic behavior, and the whole system really falls apart. And they want to avoid that ever happening at all. So these are quantitative frameworks. This marks a strong shift in how we want to manage. We want to move the flooding conditions more to the left and away from the right side of the screen. CRIDA, we never that climate is the most important driver, that it's the most significant element that we need to be able to think about. In fact, we start by saying we need to really test that assumption because climate is not relevant to everything, and we need to ensure that if we're going to talk about climate, that we're confident about the extent of its risk in terms of our decision making, our long-term decision making. Now, this is the strategy of a diagram that we use inside of CRIDA, and there's two significant columns here. On the left, the y-axis, what is the impact that we may be facing, and on the bottom is how much uncertainty do we really have in being able to quantify the reality of that risk. And that quadrant 1 in the bottom left, that assumes climate is not important or the impacts are not severe, and we know a lot about what's happening. This is kind of the business as usual position, and this may be where we are in most cases. It's also where most decision makers are, that they know that's where they start. We have confidence in our analysis. If we move up to quadrant 2, that's when we have pretty high confidence in what's going to happen, but those risks are pretty severe. We need to really be worrying about them. Those are robust solutions. That's we know that additional floods, such as in 2010, are going to happen again. We know that extreme heat days are going to continue. Those are safe bets. We can develop robust and comprehensive solutions and not to worry about uncertainty. And decision makers will see that that we need to make, we can justify a more intensive and comprehensive solutions. Quadrant 3 is different. When the uncertainty levels are high, then we need to be flexible. That's when we need to say maybe we need to hold off on a decision, or we need to make sure that we haven't ruled out other options. We may be facing floods and droughts, and potentially more extreme than we're facing right now. The most extreme case, and this is often the case for cities, is the combination where there are high impacts and there's also high uncertainty. And that's what we need to think about, being robust and flexible at the same time. And this is where in many parts of South Asia, I would say that the challenges that you are facing are in this quadrant, especially for long-lived systems. Here's an example of a particular case. This is one that we use in CRIDA that'll be coming out as a case study. This is from Zambia in East Africa, and trying to think for a large city's water treatment facility. And here, you might think that water supply would be the big issue. This is in a region that's in general drying out. This is a water treatment facility that is more and more frequently not being able to provide drinking water to the residents of this city. And they have significant shortfalls. that they're very worried about, the ratepayers are worried about, the decision makers have really become political issues. And working with these decision makers, what we've been looking at is what is the value for different types of interventions. And it turns out that water supply was not the most important issue. It actually was the water that was embedded in their electricity. This is a hydropower dependent system. They get most of their hydropower from 2 different dams. This is the intersection of climate change with the water nexus that Ali was referring to for future. And in this case, the decision was that the best value in order to be fully robust to well-known risks was actually to make sure that you were using energy systems that were not dependent on water. In this case, they went with a standing permanent generator backup system for when there were frequent hydropower delivery shortages, so that the system continued to purify water, and it's also a scalable system. Hopefully this is an example, not necessarily a flexible implementation, but for flexible thinking and holistic thinking. This is an example that's from the Philippines. Again, this is a water delivery system for a particular city. This is one a huge amount of uncertainty. If you look in the called a risk surface, and on the left, we see the amount of annual precipitation, the y-axis, and the x-axis, we see the ratio between precipitation and evapotranspiration. In effect, if you are in the bottom right, you're in wetter conditions, and as you move more towards the origin, the intersection with the y-axis, you're looking at drier conditions. So more evaporation than precipitation. In 2006, in this island in the central Philippines, it was quite wet. However, if you look at the top of this risk surface, red is bad. Red means that it's out of our safe operating space. The climate models are very mixed. They say it could be wetter, it could also be drier, and they don't give very clear guidance. But if we look on the right side in terms of demand, how much we actually really know about how the city is changing, how it's thinking about its own growth. This is a very rapidly growing city. It's increasing. So in 2030, it's around 220, a level of 220, and then increasing almost by 10% by 2030 over a relatively short period. So there's uncertainty about the impacts, but there's not that much uncertainty in terms of the social and economic areas. So how do we handle that kind of addition? In this case, it really requires a flexible response. It means thinking really about integrating cross sectors, including water users that relax some of the kind of economic benefits, and making sure that we're considering how water demand may grow. Maybe there are ways that we can slow the rate of that demand by improving the efficiency of use, by potentially developing alternative and additional water supply systems, and really making sure that we're seeing water as a river that flows through all of the different departments of this particular city, and not just as a component of the water utility. Lastly, I'd just like to say that Agua, with the support of both CIWI and the World Bank, have been developing a website to be able to build capacity around these issues. We're not just putting out publications, but we would really invite you to join our community of practice to be able to learn more, including a kind of short crash course in using these bottom-up approaches. This knowledge platform is something that is a growing and evolving a topic, and we really hope that you'll partner with us in the future. What I'd like to do now is hand this kind of a background talk over to my friend and colleague Martin Schuler with ARUP. So thank you very much, Ali and Talid. I'm really grateful, and I also look forward very much to your questions at the end of the session.
Thank you very much, John. So Chairman Ali, are you happy to make the introductions?
Please go ahead, you make the introduction. I'll just add 1 or 2 sentences. John, are you going to introduce Martin, or should I go ahead?
Chairman, please go ahead if you and introduce my me and my presentations, please.
John, can you hear us?
Yes, I can hear you. Okay, can you introduce Martin Ali, please?
Okay, I'll do that, even though we were requesting you. First, just to acknowledge that you have given a very rich presentation, and I'm very fortunate to introduce your co-speaker, who is Associate Director at ARUP. Many of us have worked with ARUP or know about its work. One of the best institutions, a consulting firm operating globally. And Martin is a water engineer in the international engineering firm, ARUP. He works on water and related projects across both building, engineering, and infrastructure, and leads ARUP's London Water Group. Is responsible for ARUP's partnership with WRCs and a new water innovation service. Martin has extensive experience in the field of public health engineering and water engineering, having been involved in a wide range of major projects. He was the founding chairman of the Society for Public Health Engineering, SOFI, and many of us have known him because of his work at SOFI. And that is a professional organization for public health engineers in the UK and across the globe. It has several hundred members, Martin, if I'm not mistaken by now. And he has served as a specialist advisor to the UK's Environment Agency, covering the water and the built environment. He is also an integral part of the World Bank, of the Rockefeller Foundation's very famous and very impactful work in the region dealing with urban resilience issues. Martin, we are very fortunate to have you, and I'm looking forward to us building upon this. We can see some of your institutional affiliations. In addition to CV and Agua, we also see you working with World Bank and University of Massachusetts Amherst, and I know that you're directing this project at the Rockefeller Foundation also. Thank you, Martin. The floor is yours.
Thank you very much, Chairman. Thank you, Ali, there for that kind introduction. And I'm very pleased to be with you from London. The sun is out in London. We're going for a very dry period at the moment. So the topic of my presentation is quite topical. But I'd like to just also thank John for a fantastic presentation. You set the scene very well and shown how broad a subject resilience are. to take you through some of the thinking that's happening at the moment in developing new ways to look at water resilience and creating a new lens to look at cities and their basins. You can see, hopefully, from the slide in front of some of the partners working with us on this project. So I will quickly go through some of the partners. You will see Agua there. So John is a partner in our work, but other names there. Siwi, you heard earlier. The Rockefeller Foundation have been very generous in their support of this project. The World Bank, UMass Amherst University in United States, and 100 Resilient Cities, amongst others. So it's attracted a wide range of partners to the project, which is absolutely fantastic, because to unlock this problem requires a multidisciplinary approach and needs a wide range of thinking to move the dial on water and resilience. So I'm going to talk a little bit about where we've got to. The project is current at the moment. We're probably 60% of the way through the project, but I'll take you on a little journey to give you a flavour of where we are. I'm just checking my slides now. You should be on my second slide. Check that the slides are reading well, Ali. Or John, can you see my slides just to be sure?
Yes, I can. I see your presentation view, but I don't think that's a problem.
Okay, so let me get full screen view. There seems to be a bit of a lag in the system here. So we may have to just persevere with this view at the moment, make that slightly larger. Okay, so a little bit about Arup. This is the company I work for. We're a consulting engineering company based in the UK, but we're international. We have around about 14,000, 15,000 now engineers, designers, planners, scientists, and consultants. We main effort, I suppose, to show you a few projects well, is delivering buildings infrastructure, but we also get involved in strategic advice to governments and to our clients. And we're based out of 90 offices across the globe. This slide shows some of the areas that we're based in. So you can see from the slide there that obviously Europe, East Asia, the US, and Africa, amongst other places. And these are places that we are currently doing business in and have project teams based. So we're well known for tricky projects. So some of the projects I've just picked out, just you may be aware that Arup's been involved in the past. This is the Sydney Opera House in Australia. It's a fantastic reference project, and we come back from time to time to work on that project. I just ran through some of the projects we've been involved in, just to give you a flavour of the breadth of the projects we get involved with. This picture just is a composite of some of the tall buildings of which we're well known for. Obviously, that is a composite there. You can see some of the complexity of structure and design that we're asked to work on. It's a great privilege to work on these projects across the globe, I think, in nature. And we also get involved in lots of water projects. I'm part of the water team. This is just a shot of creating space in a city in the UK and using water to help the regeneration of of an area of a northern town in England, Bradford. Again, here's another project showing the complexity of the design that we get involved in. You can see there at the top of that, joining those three buildings, there a hotel in Singapore is effectively a deck area with a swimming pool, and I was lucky enough to visit that project last year. But that gives you some idea of our engineering. And this is just a shot of an innovative wastewater treatment plant in Hong Kong, which, as well as treating wastewater, we've, through the client, have developed a visitor centre. So connecting people with the man-made water cycle, if you like, and understand how you can extract value from wastewater. And one more really to complete the picture. So we get involved in wastewater treatment, and this is a shot of wastewater treatment plant in Yorkshire in the UK. So hopefully that gives you an idea of the sort of engineering background that we've come from. We also get involved in looking out to the future, looking at the future drivers, so that we understand how that we can best design assets for our clients, both buildings and infrastructure. And I've brought this slide into the picture really just to understand, perhaps from a risk perception, the type of things that John touched on earlier, really, looking at sort of climate change and water risks. So if you look at the top 10 risks, you can see water appearing there in many of them in terms of the likelihood, extreme weather events. It also impacts migration. There's obviously man-made environmental disasters that have a water association. And then looking at the top 10 impacts there, you can see again water is a constituent part of many of the top 10 risks that we face globally. And John hazarded a definition of resilience earlier, and I will do too. This one I borrowed from the Rockefeller Foundation, who we've got a long-term relationship with, and I think it's a very simple one. So in terms of resilience, it's the capacity of individuals, communities, and systems to survive, adapt, and grow in the face of stress and shocks, and I'll come back to those terms, and to even transform when conditions require it. So that's kind of the resilience that underpins our thinking in terms of the definition. Always good to start with a definition. So you can see how that plays out across the globe there. You have too little water, too much water, floods and droughts. And you can see how that impacts the citizens of cities, but also into the catchment as well. So for many years, we've understood that we need to work alongside the natural water cycle. And we've taken an approach here that underpins a lot of our thinking in terms of water projects. And I've brought this one here just to see how, from a flooding, from a water supply, and from wastewater, if you can integrate those into the man-made water cycle, you've got that holistic thinking that needs to be brought to bear. And perhaps the unit there that we need to consider really is the kind of city scale, really, to bring that together. And the benefits are around the outside, the benefits and risks of some of those impacts. It affects the economy. Climate change affects natural, and we heard about it being considered as a utility earlier by John. I thought it was a fascinating way to think of the clock. Providing, but also it can actually create natural disasters, flooding and other events as well. And also to consider that water has a number of dependencies in it, which is all systems. You can't think of water on its own. You need to think of power. You need to think of transport. And again, link back to the sea in a scale to consider those interdependent and bring them together. So what is our in this space? So we get involved in lots of different strategic work, and we recently looked at developing non-potable standards, so using water of lower quality for not drinking water, but using it for other purposes. And so we've helped develop that standard, very important from an engineer, and in terms of building the confidence in these types of systems, you have to have robust standards in place. And develop tools to support non-potable systems, and these non-potable systems are now being considered in the UK on a city regional scale as a way to meet growing demands placed on our water systems. Here's another example of where we've deployed that thinking in Birmingham, second city of England. And then now we've worked with the 2030 Water Resources Group, looking at waterscape and learning from each other, publishing online resources that can be used and redeployed around the globe. So again, a knowledge exchange.
Martin, can I ask you a question, please?
Yes.
It's very impressive the work you and your organization are doing, and we are also very.
Yes, please go ahead.
And we are also very keen to learn that you have worked on UK and European standards. I was just wondering if you have a particular reflection about the relevance of some of those standards for the urban vulnerability issues, because the urban flooding in Pakistan is on increase. So I was just wondering if you can reflect if those standards are of interest to Pakistan.
So just to be clear, that the question was around about the use of non-potable water in Pakistan. Was that the question, Ali?
I think yeah, something like this. Actually, because you have worked on the British standards, and you have also been engaged on the European standards as well. So the question was that some people sitting here are very keen to learn whether or not these standards have any lessons or relevance for the urban flooding issues for Pakistan.
Okay, I think the question I heard there, you broke up, the audio broke up slightly, but the relevance of British standards for Pakistan.
Yes.
So it's a very good question. So British standards and international standards have a good relevance, and some are adopted by various regions across the globe that have connection with over years, refer back to UK standards. And often we have, because I'm a standards writer with the BSI, the British Standards Institute, work also with them, which is the European equivalent. So they are maintained. They provide best understood topics, and I would say they're relevant. But there's also very good standards coming from the US and other countries, including Australia and others. But I think the one that I referred to in my slide is a code of practice for non-potable and water reuse is equally valid in Pakistan. The systematic thinking approach, and I would commend that standard to you in Pakistan and a number of other water ones. So very pleased to take that conversation offline, but I would commend British standards, their relevance to Pakistan. So if I may, I'll go back to the presentation. And just reflecting on previous work that we've looked at, so in terms of urban resilience, and this is again work that we've done with the Rockefeller Foundation. And what we come up with is a systematic way of looking at resilience at the scale. So this is a way of thinking, philosophy, if you like, that's being deployed globe and underpins much of the 100 Resilient Cities work as well. So many cities now are undergoing this systematic diagnostic of their resilience and looking to how to enhance that moving forward. So this was, we took this, our inspiration for developing a water resilience. So many of the concepts have been taken from and the City Resilience Index, and that is translated now in with water resilience. So really is to just to think about what the opportunities around an urban water resilience concept might be. And there's, these are just a few of the things that we feel will arise from this type of thinking. So a lot of our work goes back to sustainable development goals, and we've used that as an inspiration for developing our thinking on water resilience. And I think one of the things that John mentioned in his presentation not just from a governance, and we need to be able to look to ways to strengthen that at a city regional scale. Cascading failures really is around the interdependencies of systems, and so with our work we're looking to see how water is impacted on and impacted by other systems. So a very simple way of thinking it is, if you lose power systems to an urban water system, then you're going to have negative consequences there. And then we can then look into better understanding the water-food nexus, and again, something that John touched upon. And we can perhaps, instead of being led by a very reactive response to emerging issues with water, we can actually be making longer-term decisions and taking a more proactive view. So rather than actually dealing with a particular instance like, say, water scarcity, it's better to have the longer-term planning in place to be able to mitigate some of the effects, perhaps, of climate change and other vulnerabilities of the water system. So this really defines where we are with the City Water Resilience Framework. We were very keen to explore the relationship between a city and its catchment. Previous work has focused really at the city scale. But what we are looking at is that interaction between the catchment and the city, and we have to push out, therefore, the wider stakeholders that are involved in the catchment, rather than drawing the boundary around the administration of a city. As that's one of the key facets of our work is understanding that complex relationship between the catchment or basin that the city sits within. And an interesting point also is that it may actually be remote catchment. So it may be water being provided from a remote catchment, to a city. So really understanding how those boundaries are pushed out, even perhaps beyond the initial basin lines. So what we've done is to define the city water basin in our work. We've looked at characterizing urban water resilience and the attributes related to that. But we've been very keen to learn from cities across the globe, and we've designed this to be a co-design project. And we're in the middle of our field work, and I will come back and talk a little bit more about that. But very much we're learning from cities and transferring that knowledge from city to city. So we go back to understanding that relationship between a city and its catchment, and this is just a cut through of a stylized catchment. But here you can see many of the impacts that the city has on its catchment and vice versa, from demand management and water resources, how they're connected, from asset management to downstream effects, and perhaps even thinking about the circular economy and water as well. So all of these things combine in our thinking and need to be taken into account. So these, I suppose, are the three principles that we started our work with, and we're testing these principles as we go through the work and keep coming back to them. But urban resilience cannot be achieved without urban water resilience. So we wanted to test that statement. If there was that, could we demonstrate the relationship between water resilience and urban resilience? And I think we're very much able to do so. Urban water resilience cannot be achieved without a basin scale resilience, and that's the relationship between thinking about the basin, the catchment that a city sits within, and therefore its impact on urban water resilience. And then finally, a basin scale resilience cannot be achieved without urban resilience. So all of these things are interdependent and connected. And it's, although very simple statements, they are being tested, and we're developing the evidence base to confirm these facets. So our work commenced last year, and as most projects do, we started off by looking at the state of the art, what was out there already in this space, was there a learning that we could build upon and bridge across. And so we looked at various frameworks, methodologies, and tools. And this slide just captures some of those that are out there. And the approach that we're taking is that we're creating a resource that will be all three of those, which will have an overarching framework, include a detailed methodology, and a suite of tools. So the City Water Resilience Framework sits in the middle of the intersection of framework, tools, and methodology. So we started by, through our partners at 100 Resilient Cities, by identifying a long list of cities that we would like to work with in the initial phase of the project. And we had a very successful competition, which we were oversubscribed by cities across the globe who would like to join in the so-called Wave 1 cities. These were passed through a selection process, and we were finalized with the 5 cities shown on this slide. Amman in Jordan, Hull City in the UK, Miami in the US, Mexico City in Mexico, and Cape Town in South Africa. They were selected because they share certain characteristics, but actually they also provide us with a broad spectrum of different challenges and vulnerabilities to the water system. There are different stages in their development, so we felt that we had a broad canvas of issues that we could go in and better understand. And our sent teams around the globe to capture that learning and to impart our knowledge as well. And then we're going to bring those cities with other cities back to London in August for a global knowledge share. So we're currently in Cape Town working with the resilience team and the water team in Cape Town at the moment. The other cities, we've now completed the fieldwork stage of our work. So just to understand how the city water resilience framework will operate. As I say, we're in the middle of generating the work at the moment. But there's this stage one in this figure here is really to understand the system, and we're developing tools to understand the governance. We've developed tools to understand how water interacts with the city, between the city and the catchment. So that helps us then to assess the water resilience of a particular city and catchment. And that's the phase of work that we're in at the moment. We then take that further and do a deeper dive and do the analysis and action planning. And then the cycle goes on to implement and monitor the plan, and it is a continuous cycle there. So that is the framework that we're developing currently. And we're in stages 1 and 2. So it's very early, but a very exciting stage to be in. And this is just a feeling from the team where we are about how that interacts and what that really means, those particular stages. And it's really bringing consensus into that multitude of stakeholders that interact with the water cycle from the city to the catchment. You can imagine any given catchment, there's many different stakeholders involved in that. And part of it is to understand the roles and responsibilities from a governance point of view of all of those involved in the decision making, but also the beneficiaries of the catchment. So much of the work is about understanding from a shared agenda the water cycle, bringing disparate groups together who perhaps may not interact in terms of the water cycle, and develop some consensus and understanding the vulnerabilities of what they see day to day and longer term, and capturing that to enable us then to spring off that in terms of prioritizing what interventions need to be made. This is a very simple way of considering the natural and man-made water cycle, and you can see here that this one is from Amman in Jordan. We've tried to capture the interdependencies there of the different types of systems in play and looking at how they interrelate. So every catchment will look slightly different and will have different actors. It will be set up different from a governance point of view, but they all share many of the similar characteristics in terms of the way you might characterize the basin and the city interaction. And this we found is a very powerful tool, and we're developing this so it becomes an online resource, so you can see how those interactions work, but also that becomes an engagement piece then for actors in the water cycle. So on to a bit of a more detailed look at the assessment tool. So this is the lens that we can, the water lens, if you like, that we can look at urban resilience through. And it consists in a very similar nature to the City Resilience Index of 4 dimensions, which are the inner ring there. It happens to have 12 goals and a number of indicators. And I'll take us through those dimensions and goals shortly. So we see direct parallels between the water resilience and urban resilience in terms of thinking about health and well-being, because once you start thinking about why are these systems in place, you quickly come back to they're there to serve the citizen. So therefore, they need to be able to speak to health and well-being, and they need to understand human vulnerability. They need to be able to speak to livelihood and employment, and they need to understand minimum safeguards to human life. These are captured in our water resilience tool, and this is the health and well-being dimension.
Martin, how many more slides you have?
Say again?
How many more slides you have? Because you have 5 more minutes or so.
I've got about 10 more slides.
So you think you can wrap up in 5 minutes or so? Because we want to close at 10 and we do want a little bit of time for question and answer.
Okay, that'd be absolutely fine. So these slides will be available after for anybody who wishes to have a more detailed look.
Excellent.
But the next few slides I will quickly just show, but that's the dimension for economy and society, which forms the second of the quadrant pieces for the tool. Infrastructure and ecosystems is the third dimension or quadrant. And governance and strategy, which you could argue actually is probably the most important from my perspective in terms of water resilience and understanding that joined up approach. So those four quadrants are being tested in the 5 cities across the globe, and they create the water resilience assessment tool. I'm going to quickly go through some of the challenges that the cities face that we've visited in the recent past. Amman in Jordan, water scarcity is high on their priority list. They also have an issue with increased population. Some of that is forced migration from other states such as Syria, which is impacting on their water resources and their ability to serve their populace. They're also looking at other sources of water such as desalination. Cape Town in South Africa has been in the news over the last 12 months or so, and they suffer from both droughts and floods, and they're in the middle of a water scarcity period at the moment. So very vulnerable to both of those challenges, and needs to push out their thinking out into the basin to support Cape Town and other economic uses of water in the catchment. Miami in the US faces huge challenges with sea level rise, extreme weather events, is prone to flooding, has issues with groundwater abstraction and saline intrusion. So again, has a number of challenges that we are learning from, and we can help to bring that learning into the city water resilience framework. Mexico City, issues there with growing population and water transfers, wildfires and earthquakes, quite seismic area, all affecting the urban water cycle. And finally, in the UK, we're a small city on the east coast of England, again, very prone to flooding, and has been flooding on numerous occasions, and it's affecting some of the economic drivers in the city. So that was really just a quick rattle through of where we're at. We're due to finish this work at the end of the year with that diagnostic tool. We're actually now in the process of inviting 5 more cities to participate in the project. So they will enhance our learning and bring in other dimensions and understanding into the tool. So I'll leave it at that point because I want to, as Ali suggested, leave it open for some questions. That's where we are with the framework. We're very happy to share work as we go through, and perhaps if I'm invited back again, I can give you an update on where we've got to. But I'm happy to take questions alongside John now, but equally if these slides can be shared to the audience and others want to come back at a later date, very happy to do so also. So I'll hand you back now to Ali, our chair.
Thank you. Thank you, John, for such a fascinating journey across the cities and such a rich conversation. Before I open the floor, we have about 15 minutes or so at best. Let us to close on the scheduled time. And also there may be some people on the webinar that may be asking some questions. I can make only one short comment and then open the floor. It is very interesting, and I hope, John, you're there, how seamlessly these two presentations are connected. They look very different, but I think after the survey that John gave of various basins and systems, rivers, across different continents, it was coming very clear that end of the day, the challenge is at the local level, for which you need a bottom-up decision-making process or tool that is robust and flexible, and the decision-making expands, investments expand because of robustness as the challenge grows. Otherwise, the variables in terms of short climate models, the options they offer you over 100 that go beyond about a dozen or so, typically followed by IPCC. So it's the robustness and flexibility of decision making that is essential to respond to a challenge that's growing. On the other hand, I think John picked up from there after briefing us how important work Arup is doing in different parts of the world. I think he also highlighted that no city is resilient unless it's water resilient also. So water resilience is at the heart of our resilient cities. And we see that. We have seen that in the shape of drinking water. You've seen that in the shape of depleting groundwater in another part of the country or South Asian region. We have seen in the shape of horizontal expansion, eating up the catchment area of urban water supplies, and we see that in Islamabad also in recent years. So, in a number of ways, I think what Arup has pointed out, that all these frameworks, all these methodologies and tools will end of the day hinge on three key components. How best you protect the catchment areas of the cities, how usefully you can co-design, that links up with what John was saying, and how far you can make city resilient to urban challenges. And I didn't mention urban flooding, which is also on the increase. I know John and I know Martin that it's not a fair summary because your presentations are much richer than this. But at least to bring it to some point on which people could react, I wanted to put 1 or 2 sentences on the table. The floor is open. If any comment, any question, any observation, we have time. And please do introduce yourself if you feel comfortable.
Okay, thank you, John, and thank you, Martin, for making these very wonderful presentations. I am Dr. Hassan Abbas, and I'm from Pakistan. My area is water resource management. Having said that, I will just make a kind of a comment which would follow a question from both John and from Martin. Now, I was quite impressed with the presentation, both presentations, and one of the things which intrigued me was the picture of Patricia Mulroy. Actually, Mulroy is one of my inspirations in water management, and like Patricia Mulroy, there are another two who are my inspiration in water management, and those two characters also come from USA. One was Floyd Dominy, who was the Commissioner of Water Bureau in US, and another one was Mulholland, who is kind of the father of water management in American West. So, but these three people, Patricia Mulroy, Floyd Dominy, and Mulholland, they had their visions first of all, and the vision of the vision of Floyd Dominy and Mulholland was kind of the same. They both had a vision of conquering the natural water and using it for the human beings. In other words, they wanted to tame the natural waters and let it be used by the human beings. Patricia had a completely opposite vision. She wanted to tame human beings to conform with what is available. There's a very famous thing about Patricia Mulroy. When she came to LA, she was of the opinion that these fountains were wasteful, and she wanted to cut down the water on all those water fountains around the rivers. And then the LA community, again, this was the social and economic side. They said that if we stop running our fountains, we lose business. And one of the therapists, he was running a fountain in his clinic. He said that I need that fountain running because the sound of the water is part of the therapy. And Patricia said, well, why don't you use recordings? So that is how she forced herself. And about the hotels which were using those fountains, she said, okay, if you want to run those fountains, recycle the water from your laundry and use it in the fountains, and I don't mind. Whereas Flight Domini and company, they had a vision that if the water is flowing in the river, it is wastage. And they came with that vision even to India and Pakistan. And they told us to dam and divert our rivers. If our water is going down to the sea, it is not good, it is wastage. Now, with that preamble, my question to both of our worthy speakers is that what do you think should be the vision today for Pakistan? Because both of you have seen a lot of the world, and especially John, he had been to Pakistan. He knows a lot more about Pakistan, and I'm sure Martin also, with that kind of global experience, has some vision about cities. And I don't know if you had been to Pakistan, Martin, but what is your vision, Martin? This is for you. What is your vision about Islamabad water future in Pakistan? And John, what is your vision about the overall future of water management in Pakistan? Thank you.
All right, thank you very much for the question. I think it's a very complex question that you posed there, but a very interesting one nonetheless. I have worked in your region of the world, but not in Pakistan directly. And actually, interestingly, I was in Nepal very recently, where we were looking at the so-called water initiative in Southern Asia, which Pakistan sent a number of expert engineers to. So we have connected there, and it was around the piece looking at water holistically. So rather than thinking of water as a system that on its own, is to look at how it impacts across the catchment and basin, and how we as people need to draw value from it. So I think I would actually suggest that the approach that we're taking with the city water resilience framework would provide a way to look at Islamabad and any particular city in Pakistan, because what that does is look at the wider governance issues, looking at those competing needs for water, and obviously, Pakistan is facing, potential water crises in the not too distant future, with more demands being placed on water systems. So I think by having that foresight and planning, and making those decisions at the right and appropriate time, that would be my sort of one piece of advice for Pakistan, is to take a holistic view, understand the wider governance of water, and take those decisions to address the vulnerabilities in the man-made water system. That would be my one piece of advice.
This is John, and Professor Abbas, I really appreciate your question. I'm very impressed as well with your knowledge of some of the iconic figures in U.S. water history, and I'm so pleased too that you also shared an admiration of Patricia Mulroy. I think she's one of the great voices that we really have on water and sustainability. My sense about I certainly echo Martin's comments, and thinking about water governance as a way in which we're trying to negotiate these trade-offs between different stakeholders, and also in a larger sense about changing water conditions. The way that I've come to think about Pakistan is that it's really squeezed between two, maybe three reservoirs of water. One is down low. It's some of the most intensive, if not the most intensive, groundwater consumption in the world, and that clearly can't continue. That's I would actually say that the economic behavior activities that are based on that groundwater are founded on a hydrological and climatic lie, and that's really concerning. It can't continue, and it has the potential for creating even lasting, permanent negative impacts to the good people of Pakistan. Then up high, there's also the reservoir of the mountains, the snowpack, and I actually disagree with some of the stated studies that you see in places like the IPCC. I feel like when you talk to many of the researchers who are working on the glaciers and snowpacks of the Himalayas, that they're not really able to say, I think in many cases, what they really fear, which is that we don't know as much as we think we do. That our level of confidence about the long-term status of that snowpack is very different. And then lastly, the third reservoir is the South Asian monsoon itself, and we know that is also changing. It's becoming less reliable, more variable, and so Pakistan is squeezed between three rapidly changing reservoirs of water. So I think, that Martin's point that governance is the place where we're trying to navigate between these three reservoirs is a really critical point. I also think that means that maybe the long-term vision for Pakistan, one of the things I was really struck by in working with the provincial government in Punjab was I had really never met so many really smart, extremely well-educated and thoughtful civil servants in any country, and that the level of expertise was very, very high, and the level of articulate awareness was very high, and I think that knowledge in combination with civil society needs to consider what happens about the journey that Pakistan is beginning down to becoming primarily a rainfall country, where most of the water is on the surface. Maybe some of that surface water is also used to really be able to recharge aquifers, but that snowpack and glaciers are really a diminishing and probably at some point an inconsequential part of the system. I think, based on the archaeology, Pakistan has probably been there before. Based on my read of the archaeology, about 5,000, maybe 5,500 years ago, Pakistan went through a very similar crisis during the Holocene. But this is happening quite rapidly now. There are a lot more people in Pakistan, and there's a lot more that's at risk. So my hope is that the economy and the society of Pakistan can begin to move. That is perhaps the best kind of vision for what a resilient system looks like. Thank you.
We have we're beyond our time, but let me take three comments together, and I'll request the speakers to give a combined answer. I noticed your hand first, sir. Please do introduce yourself so that the speakers also know.
Hello, my name is Gamze Ali Sial. I am working in SDPI, that is Sustainable Development Policy Institute, and we are working on pathways to resilience in semi-arid economies. So basically, we are focusing on three districts that are Dera Ghazi Khan, Faisalabad, and Mardan. And we are working on three core areas, that is water governance, migration, and cotton value chain. So I'm thankful first to the lead organization that they have organized this webinar and asked great experts like Martin and John here. But I would be discussing about I would be adding a comment in case of Pakistan that we already know that we are a rising nation, that we have got increasing demand of water, and SDG 11 and the Vision 2025 are talking about the urban development and all infrastructure. but something is missing. It's about the solution that we should be talking about here today, and one of that is discussed in the Vision 2025 is about smart cities. There's the concept of smart cities, but on the implementation side, still there are some lacking gaps that we can know how we would be going to implement the smart cities projects in Pakistan. And along with that, I wrote an article on urban flooding, and in that, they've got few solutions just like in other countries. First is the wait campaign in New York, Brooklyn. Question, please. And just a comment, just solutions. Oh yeah. So first is about the wait campaign. Second is about creating spawnage cities in Wuhan in China, and third is about the rooftop gardens in Europe. Okay. Fourth is about creating flood plains for emergency overflow. Fifth is about creating separate drainage from rainwater. Sixth is about building underground tanks to store water. And seventh is about developing green sidewalks to add not only the aesthetic sense but also the micro carbon sinks. So these are the few solutions I would like to add in terms of
That's where this robust decision making comes. People have to take charge of their and have local levels. Yes, sir.
Thank you very much, sir. Hello, John and Martin. Thank you very much. My name is Shahryar, and I am my area of expertise is inland navigation. So I am particularly interested in the non-consumptive use of water resources, basically the urban and rural environments of Pakistan. John, this might be more related to you because whenever we hear about the water policy and the future vision of Pakistan, in case of water economy, we only talk about the agriculture production. We have never heard the word intrinsic value of water, or the water of just, or the creating value from non-consumptive use of water. That might include the inland navigation within Indus, or the systems that utilize the intrinsic value of water. So, what is your take on this? Shouldn't it be made the part of our vision, or is it being in the pipelines, or are you thinking of doing it in your work in future? Thank you very much.
One more comment? Yes, sir.
One more comment. This is Lokesh Ali. I'm an environmental specialist. My question would be, in the world, where have you experienced the low-cost solution for recharging the groundwater? And those practices anywhere, whenever we have these urban floodings and all that, can we use those practices in a very low-cost manner? Because Pakistan cannot afford much.
Okay. Allow me to have at least one more question. Yes, ma'am.
Yeah, thank you so much. This is Dr. Shahzavani. I'm a public policy consultant and currently working in the Prime Minister's office. My question is that, is there any Pakistani city included on the list of those 100 cities? And I mean, if there are any Pakistani cities, what are the comparable vulnerabilities of that particular cities with the other most affected of the around the globe? Thank you.
Good. So you have 4 questions or observations, and maybe you can divide amongst yourselves, or both of you can cover all 4.
So perhaps I could take the last question first, if I may. The question was whether we had looked at Pakistan directly in development of the tool that I described. Currently, the 5 cities that we've gone out to were the ones I've listed, which obviously didn't contain a city from Pakistan. But we are now going out to invite cities to join the project. And if we get an application from a city in Pakistan, then we'll seriously look at that as well. So that will require some working with us, so some capacity available from a particular city. But we'd welcome an application from Pakistan, and we can show you how to go about that, perhaps after the call. And I think then I heard the very first question, I think, was related to sponge cities and infiltration. And obviously, there's huge amount of benefits in dealing with water locally and slowing it down. And there was a point made about recharging aquifers. So the closer we can mimic natural systems with our engineered systems in terms of water, the better, as far as I'm concerned. We will always have grey infrastructure, but then we now talk about blue and green infrastructure. So using the natural resources to support the grey infrastructure. So the way I see it is that we can, when we bring those three systems, the blue, the aquatic environment, the green, so green and SUD, sustainable urban drainage systems, together with our grey infrastructure, the man-made infrastructure together, we can work that in harmony, we will get a better result, a more resilient result, and that brings us into sort of natural infiltration systems, and sponge cities naturally falls from that as well. Unfortunately, my time here with you today is coming to an end, so I'm going to have to leave the call. But thank you very much for the opportunity to speak today to guests in Pakistan, and I very much thank you for your questions and your time, and I look forward to connecting with you in the not too distant future. So thank you very much for the opportunity.
Thank you, Martin. Thank you for taking time, and thank you for sharing your experience and insights. John, you want to add anything to these 4 questions? Maybe he's not connected, or maybe he's in the distance. I'll try to conclude if he comes.
So I will apologize to leave now because
yes.
Someone is waiting for me.
Yes, please. Go ahead. My apologies, we are beyond our time. Typically, we try to conclude, but there were, since 2 speakers, it took a lot of time. It was a very important talk in many ways because incidents of urban flooding, it's at the heart of our development challenge. For 3 reasons. And as a Pakistani, because they're not foreign speakers, I wish to highlight. What have cities growing, we have sprawl growing, which is essentially taking fertile land, catchment areas, away, and that is.
So
Go ahead. We are waiting for you.
Oh, I apologize. I heard 4 questions. The first one, was it about sponge cities or smart cities?
Smart cities.
Smart cities. That's what I thought. So smart cities, inland navigation, and the value of water, aquifers, and then the Resilient Cities program. So smart cities, I think are really exciting, and to me, it's about really quickening our decision-making process and making sure that we're linking data in more or less real time. And so smart cities is also not just about on-the-ground technology. I have some involvement with NASA, for instance, and was recently at a 3 or 4 day NASA workshop. And the ability to use real-time or near real-time satellite data, remote sensing data, is very impressive. And I actually think that Pakistan is well prepared for that, even kind of short-term weather and climate forecasting that may be really critical for some types of variables. So I think that there's a lot of promise, in the same way that South Asia as a whole seemed to skip a lot of the way that we were thinking that telephone systems would develop, from landline-based systems just straight into cellular-based systems and mobile systems. I think that there's a real opportunity for a rising Pakistan to be able to embrace the smart cities concept. I'd love to talk more about that at length some other time. I also completely agree with the second question about inland navigation and the value of non-consumptive water uses, that we really need to include these systems into our assessment of what water is worth to us and how we prioritize. That in fact is also turning out to be a really important climate impact in places such as the Mississippi in North America, or the Danube in Europe. we've seen quite dramatic climate impacts during low water periods on navigation, for instance, and regional shipment of and movement and transport of inland waters. And being able to manage for that is really critical for a lot of internal economic development. So being able to make sure that policymakers really understand that internal connectivity is really critical, especially because it's also very low carbon. Aquifers, gosh, I love to talk about aquifers. I actually, you know what, the reading that I did and research in the Indus and the kind of greater Punjab region, the 5 rivers of lower Pakistan, I actually think that we have an opportunity here, like in many places, that we're not just seeing floods, we're not just seeing droughts, we're seeing both of them. And what I would, if I had a single recommendation for aquifers in Pakistan, it would be to harness those floods, to actually create groundwater recharge zones and aquifer recharge zones, really isolate the extreme floodwaters that we know are going to keep coming, and use that as a way to super recharge our groundwater over very intense periods. I think the other alternative is from an inexpensive perspective, especially for smaller rivers or seasonal rivers, is the use of sand dams. That's been widely explored in East Africa. I think the French developed it originally, and they've been very widely implemented and used in East Africa. And I'm really surprised that other parts of the world, in the Americas or in any part in Asia, really haven't explored those.
John,
but those are very inexpensive. Yes.
John, this is
yes.
fascinating experience and insights, and I'm sure we want much more time with you, and we'll probably need to bring you a speaker again. And next time, if I invite you, I'm going to invite you on another issue on which Pakistanis are very deeply interested. That's climate-sensitive approaches to environmental flows. That's an issue in Pakistan.
Fantastic.
Environmental flows. But please allow me to thank you very much. It was really a delight and a privilege to have you and Martin. Two of you work seamlessly. I don't know how close you work in your real life, but in presentation it seems that you have breakfast every morning together. So I want to thank you, and I want to thank everybody sitting here. And there's a much larger crowd, and I wish I could show you this, or maybe my colleague Abbas can on the camera. But then there are a large number of people who have signed up, and I couldn't accommodate any of those questions. And I want to thank webinar people. Please join me in thanking both speakers. And join us for a cup of tea just behind this wall. John, it was very nice of you, and you have covered a very large range of issues. And I'll have an offline conversation with you sometime.
Thank you. I would encourage anyone to please reach out to me by email or Skype, and I'd be very happy to stay in contact. I'm really grateful and very honored, Ali, to be working with you in LEAD. Thank you so much.
Yes. Thank you.